How did ancient humans survive serious injuries? You break your leg today, and several systems immediately begin working on your behalf. Someone calls an ambulance. An X-ray identifies the break. A doctor moves the bone into position, and a cast prevents you from testing whether walking on it was secretly possible after all. An ancient hunter could suffer the same fracture several kilometers from camp. There was no ambulance. The nearest person with medical training was whoever had seen the most injuries and remained willing to look at another one. The animal responsible might still be nearby, which made the initial consultation unusually tense. So how did ancient humans survive serious injuries? Many did not. Heavy bleeding could kill within minutes. A wound contaminated with soil or animal saliva could become infected. A badly broken leg might prevent someone from reaching water, gathering food, or keeping up when the group moved. Yet archaeologists repeatedly find bones that healed after severe trauma. A healed fracture records time. Bone begins forming around a break only after the injured person has survived the first days and weeks. Extensive remodeling can show that they lived for months or years afterward. Every healed injury, therefore, contains two stories. The accident is visible in the damage. The recovery is visible in the repair. The first priority would have been stopping blood loss. Direct pressure works whether or not the person applying it understands circulation. A tight wrapping made from hide, fiber, or cloth could hold material against a wound. If an injured limb was still bleeding badly, pressure above the wound may have slowed it. Most of these treatments leave no archaeological trace. Leather rots. Plant fibers disappear. The person who pressed both hands onto a wound leaves no mark on the skeleton. What remains is the person who survived long enough for bone to react. Broken bones presented a slower problem. A fracture heals better when the pieces remain aligned and the injured area stays still. People did not need a modern theory of bone growth to notice that moving a broken limb made things worse. Straight branches, bark, woven material, or padded hide could create a basic splint. Direct prehistoric evidence for splints is rare because wood and fiber usually decay. Later ancient Egyptian burials preserve wooden splints wrapped around damaged limbs, showing that early societies had developed practical methods for stabilizing fractures. Some of those splints used bark, linen, and grass padding, materials that are simple enough to have much older origins, even when the evidence itself has vanished. A splint was only the beginning. Someone with a broken leg could not collect water easily. They could not run from danger. They might struggle to use the toilet without assistance, an area of medical history that receives less heroic artwork than it deserves. Recovery required other people. They had to bring food, maintain the fire, protect the injured person, and sometimes delay the movement of the entire camp. If the group needed to relocate, the patient had to be supported, carried, or left behind. The skeleton shows how far this care may have gone. Was a Neanderthal who lived tens of thousands of years ago in what is now Iraqi Kurdistan. During his life, he suffered a crushing injury around the left eye, lost most of his right forearm and hand, developed problems affecting his movement, and probably experienced severe hearing loss. These conditions did not all occur at the moment of death. The bones healed and remodeled, showing that he lived with major physical limitations for years. Researchers have debated exactly how dependent he would have been, since disability does not automatically make a person helpless. Still, surviving the acute injuries and continuing life with limited mobility and hearing almost certainly became easier because other people adjusted around him. Shanidar 1 also reveals why injured people may have remained valuable. A person who could no longer hunt might still make tools, prepare food, watch children, maintain fire, teach routes, or remember where animals gathered during a bad season. Physical strength was useful, but it was never the only thing a human group needed. An older, injured person could carry decades of information. Leaving that person behind meant losing the information too. Then there is a discovery from Borneo that pushed prehistoric medicine into much stranger territory. In 2022, researchers described the skeleton of a young person buried around 31,000 years ago in Liang Tebo Cave. The lower third of the person's left leg was missing. The ends of the tibia and fibula showed extensive healing, and the research team concluded that the limb had been deliberately amputated during childhood. The individual survived for at least another 6 to 9 years. This was not a toe or a finger. Someone removed part of a child's lower leg in a tropical rainforest thousands of years before farming, cities, or written medicine. The surgical interpretation has been challenged by researchers who suggested that severe accidental trauma might explain the bones. The original team defended its diagnosis, arguing that the shape and location of the damage did not fit an ordinary fracture. The debate continues because archaeology rarely hands over a complete patient file. Whatever caused the loss of the limb, the long survival is difficult to ignore. The young person lived in steep, rugged terrain with heavily restricted mobility. Their group had to help during the recovery and probably long afterward. If it was an amputation, the procedure required several problems to be solved at once. The person performing it had to cut through tissue without causing fatal blood loss. The wound had to remain clean enough to avoid a lethal infection. Pain and shock had to be managed somehow. During recovery, the patient needed feeding, washing, warmth, protection, and regular movement to reduce the damage caused by lying still. The researchers suggested that local medicinal plants may have helped with cleaning or pain, although no surviving dressing tells us what was used. What the bones show is that the patient lived. 31,000 years later, the treatment notes remain frustratingly unavailable. Ancient humans may have known more about wound care than the archaeological record can preserve. Hunter-gatherers handled plants constantly. They knew which leaves caused irritation, which sap numbed the mouth, which materials repelled insects, and which preparations affected pain or swelling. Knowledge gained while treating small cuts, burns, bites, and infections could gradually be applied to more serious wounds. This does not mean every prehistoric group possessed a hidden modern pharmacy. Remedies could fail. A useful plant could be given in the wrong amount. Ritual explanations and practical treatment probably overlapped. Someone might clean a wound because experience showed it helped, while explaining the result through spirits or purity. The explanation could be wrong, while the patient still benefited. Keeping a wound clean would have been difficult. People lived around soil, smoke, animal remains, dirty tools, and insects. Even a well-treated injury could become infected days later. Open fractures were especially dangerous because damaged bone could be exposed directly to contamination. A person might survive the initial accident and seem stable, then develop fever, swelling, worsening pain, and eventually sepsis. Ancient care could improve the odds. It could not make the odds pleasant. Some injuries forced people to become unexpectedly ambitious. Trepanation involved cutting, drilling, or scraping an opening into the skull. The practice appeared in different ancient societies and may have been used after head trauma, perhaps to remove damaged bone or relieve pressure. In prehistoric Peru, archaeologists have found hundreds of trepanned skulls. Many show new bone growth around the opening, proving that the patients survived the procedure. A study comparing Peruvian examples found that estimated long-term survival improved over time. In the earliest group studied, around 400 to 200 BCE, roughly 40% showed evidence of survival. In samples dating from around 1000 to 1400 CE, the estimate reached as high as 91%. The practitioners seem to have improved their methods through accumulated experience. They learned where the skull was safer to open. They learned how deeply to scrape. They learned which techniques produced fewer deaths. This was medical knowledge developing without microscopes, anesthesia machines, or sterile operating rooms. The patient was presumably expected to remain still while someone approached their skull with a sharpened tool and a great deal of inherited confidence. The results suggest that some practitioners became remarkably skilled. Serious injury also changed the daily organization of a group. Someone had to replace the injured person's work. Food had to be shared with someone producing less. Travel might slow down. A family member or companion had to spend time providing care instead of gathering resources. This made caregiving expensive. It also made it valuable. Humans live in groups where the injured person today may become the caregiver next year. Supporting someone protects relationships, knowledge, and future cooperation. Researchers studying the evolution of care argue that helping sick or injured individuals has deep roots and is not limited to our species, although humans developed it into an unusually complex social system. One case from Neolithic Vietnam shows how extensive that system could become. A young man, known as Man Bok Burial 9, developed severe paralysis during adolescence and survived into adulthood. Researchers concluded that he would have required continuous assistance with movement, food, hygiene, and protection for years. His community did not provide temporary help until the immediate crisis passed. They reorganized part of daily life around him. Cases like this complicate the usual picture of ancient survival. We often imagine prehistoric life as a permanent test in which anyone unable to hunt was immediately removed from the cast. The bones describe something more social. Ancient groups cared for people who could not move normally. They kept injured individuals alive through long recoveries. In rare cases, they attempted surgery complicated enough to remain dangerous in much later hospitals. They also failed frequently. Some fractures healed crooked and left permanent pain. Some wounds became infected. Some injured people died before bone healing could begin, leaving archaeologists unable to reconstruct what anyone tried. The archaeological record naturally favors success. A healed bone belongs to someone who survived. Failed treatments usually leave less evidence of the effort. So how did ancient humans survive serious injuries? They controlled bleeding when they could. They stabilized broken limbs, cleaned wounds, reduced movement, and used whatever practical knowledge their group had accumulated. Their most important treatment was often another person. Someone carried water, someone shared food, someone stayed awake, someone altered the route because the injured person could not travel quickly. Modern medicine surrounds the patient with institutions, machines, drugs, and specialists. Ancient medicine began with a smaller decision. The group could leave, or the group could wait. Many injured people survived because somebody waited. Thanks for watching. If you enjoyed this, subscribe for more. See you in the next one.